Welcome to Happy Path Programming. I'm Bruce Eckel.
I'm James Ward.
So, I have exciting news.
Yes.
I finished Atomic Kotlin.
Woohoo!
And I know I thought I finished it at the beginning of September, but then we spent 3 more months going over and doing way more stuff than we imagined.
It's always the last bit that's the hardest.
It is, but it's way better now. So
Yeah.
I'm glad we did it, and I am proud of the result.
And for those that don't know, Atomic Kotlin is the newest book that Bruce has been writing with Svetlana
Isakova.
Yes.
Who is she was on the Kotlin compiler team, and she is now a
developer
advocate. Yeah, for JetBrains for Kotlin. So she goes around and
talks about Kotlin.
So
I just printed out your book from the PDF. Thanks for sending me the PDF, and it is thick. You put a lot of work into this.
We did, and we took a lot of stuff out.
Wow.
Yeah, we did. Man, there was something I worked on for 3 months, I think, and then at the end we decided I'm planning on putting it up as a blog post. It had just gotten too big and involved, and it was kind of like a small book to itself. It was on object-oriented design, and in Kotlin in particular, and there was this elaborate example with robots running through mazes, and it was a lot of. Anyway, that'll be a blog post eventually.
Nice.
And just this morning, I put the print version of the book and the cover into
LeanPub.
No, not into LeanPub. From LeanPub, they actually generated the layout for the book to be printed.
Okay.
And
then
that goes to Ingram Spark.
Okay.
So right now it's just waiting for them to come back and say this will work or this won't work, and then we'll do an actual press run. If you haven't, we'll do 1 or 2.
Yeah.
And if you haven't gotten too far,
for sure,
then that would be the good one to mark up.
So pretty soon I'll be able to buy it on Amazon and then give you a 1-star review.
Amazon or your local bookstore. Yeah. And it has to be very crotchety. It has to be very crotchety, sarcastic 1-star review.
Yeah. I can't believe he used a var.
Yeah.
Unbelievable.
There are a few places we did. It seemed like there was no way. I'm sure I'm wrong, but at the time it seemed like there was no way out but to use a var.
Yeah.
But mostly it's vals. Yeah. To set a good example.
There is a version of Stockholm syndrome for mutability.
You mean where you just everything you feel like a huge failure if you use a var?
Yeah.
I think I'm there. I feel like it's it's like, wow, my brain isn't working right if I have to use a var.
Yeah.
So, yeah.
That's true. So pretty soon people will be able to buy it, and that's great for people that are getting into Kotlin, and I'm sure I'll learn some things from it. I'm going to start reading through my self-printed copy soon. Oh, and people will be able to buy digital versions probably
right now.
the
LeanPub version is up there right now.
Nice.
So
atomickotlin.com.
That's right. That'll take you to everything that has the examples that you can compile, the exercises and solutions that you can work through after each atom.
Nice.
And
tell people about atoms. So the whole name, Atomic.
The name, the Atomic, and preceding this was Atomic Scala, which I did with Diane Marsh. And the idea was that we wanted to, like an atom, which at the time was thought to be the smallest unit of matter. The idea of this is each of these little tiny chapters are so small we couldn't break them down any further, so that it's a single concept. That's the goal. Sometimes some things later in the book have gotten bigger because they're more complicated and they need more coverage, but we still try and.
They're very heavy atoms.
Sometimes, yes, they're heavy. Yes, and they're later in the periodic table.
That's right.
In the analogy of the book.
Yeah.
They're further down. So,
So one of your philosophies for your authoring of these atomic books has been to not have forward references.
As much as possible. Every once in a while, if we're talking about something, we realize, this could leave you hanging. we do say sometime later we will talk about, a follow-on to this topic, but we don't say, of course, you could use a generic here when we haven't introduced generics yet. That just seems...
Yeah. So as much as possible, no forward references.
Yeah.
But I'm sure there are things that are just kind of almost naturally circular in their definitions. And so that you can't avoid it in a circular...
You can pretty much... You have to craft your examples carefully so that you're just using stuff from, you can write hello world except in Java, without knowing a whole lot of things about the language. So this is kind of like that.
You have to know a function.
You have to know function calls. You don't have to know what functions are.
Yeah.
So you just...
So you have to, before hello world, you have to introduce function calls.
Yeah. And we usually comments and... Yeah. And you have to define a main. So you do actually have to know a little bit about defining a function.
I guess you could do a KTS and not, the Kotlin script.
Oh.
And then you wouldn't even need the fun main.
I think when we got started...
It's pretty new, like the KTS.
Yeah, I don't think Kotlin scripting was... I think it was still a gleam in somebody's eye at the time. Whereas I think Scala scripting now is to the point where you could write a Scala script and somebody could put it inside of a main and have it work.
Yeah.
Or maybe it just looks the same.
Yeah. Well, it's super exciting.
Yeah.
I think this will be really useful.
3.5 years of work.
3.5 years.
I know.
Dang.
Long time.
Dang.
Yeah.
Well, hopefully you'll make more than the 10 cents an hour that, that's typical for books.
Yeah. It'll probably be fun.
Do you look at it as a hobby or
more and more?
Yeah.
More and more. And I think I would rather look at it that way, because when you're doing it for satisfaction's sake, it tells you how to make decisions. It's like, is this fun? If it's not fun, why are you doing it?
Yeah.
That kind of thing. So, and that kind of follows into you and I and Bill Frazier are starting work like almost immediately, just because of random timing things, on Atomic Scala 3.
That's right. So with Scala 3, the Scala 3 language coming out, with some pretty significant changes to the language, we're like, hey, it'd be cool to update the Atomic Scala book to Scala 3 and use all the fancy, significant white space and, all the other fun features in Scala 3.
Right. And a lot of the work that's gone into the Atomic Kotlin book.
Yeah.
That's improved things over the Scala book, I think.
Yeah.
Anyways.
Yeah. Yeah. I think there's so much overlap between Scala and Kotlin now. Yeah. Like Scala 3 has extension methods like Kotlin has. So yeah, it's going to be fun. I think that
is the point of the book, is that it be fun.
Yeah. It's a hobby.
It is. Well, because, there's not a huge number of Scala programmers, but maybe we can help the people who are interested.
Yeah.
Because it'll also be a very careful step-by-step, and Atomic's reasonably introductory.
Yeah.
It maybe not the language I would choose for a first-time programmer, but who knows?
Yeah.
If I guess I've learned so many times people had come up to me and said that they had learned to program from thinking in Java, which was not the point at all of that book. Huh. And so I realized, well, no matter what you do, people are going to try and use it to learn to program. So might as well at least make it
try to support that,
accessible with them in mind at some point.
Well, one of the nice things about the Scala, Atomic Kotlin, the way that you structured them, was that like for me, I don't know 100% of the Kotlin language. I don't know what percentage I know, because I don't know what I don't know. But I think that I could easily skip, let's say, the first 20 atoms or something like that before I got to something that I'm like, oh, this is something I don't really know much about. And so the way that you've structured it into atoms makes it so that no matter what level you're at, you should be able to find a place to start and move forward from there.
Well, plus we have these 2 summary atoms for people who are experienced. So if you're experienced, you can just go to summary 1 and it kind of, here are all the features that we covered in that section of the book. And then you go to summary 2 and then you're up to speed for moving forward atom by atom. So that way you don't have to like guess. Yeah. And then if there's a feature you're curious about, you can generally go to the table of contents and you can find the topic and go to it. So
nice.
Yeah, which is really nice because Markdown and LeanPub don't do indexes. I mean,
like generated index.
Yeah, they don't. Well, yeah, it's like there's really no way to make indexes with them.
Huh.
So the size of the atoms means that you can sort of say, well, the atoms
Your chapters are essentially the index.
Yeah.
Yeah.
Something like it. So, and they're so small that, they work.
Yeah.
Anyway, that's the hope. I'm hoping that people won't miss an index too much. Some people will.
Yeah. And you've got all the code samples for Atomic Kotlin up on GitHub somewhere. So
yeah, with extensive, careful instructions on how to install them and run them.
Nice.
Yeah, and then the exercises and solutions are also available that way.
Nice.
They have the examples as well, so you could just do the exercises and solutions and you get the examples. But
nice.
Anyway, this was our way of testing everything and making sure all the examples were correct.
Yeah.
And
yeah, I think that's one of the things that you've put a lot of work into in your books that makes a big difference, is that you make sure that your code that is in the book actually compiles and produces the expected output that you have listed in the book, which is really nice for the reader. Because I definitely come across a lot of programming books and tutorials where it's like, this thing just doesn't even work. Like, did you test this thing? No.
Well, they did once.
Yeah, that's right. And then they changed it.
Yeah, that's the thing. It makes it a lot easier to... And as new versions of Scala were coming out, we would just plug it in. And if there was anything that caused problems, we'd know immediately and fix it. So, yeah, it's very reassuring because I don't want to put something out because I've been frustrated by the same thing.
Yeah.
You just, you could almost open a book anywhere and look at an example and go, that isn't right. That won't even compile.
Yeah.
I think at least they should be able to compile. Yeah, I started doing this back with thinking in C++. It was the first place that I did it. And I wrote an extractor in C++ that would extract it and make files and, the whole thing. And then that took me a couple weeks to write that in C++. And then I started using Python and I wrote it in... Well, of course, I had the experience of writing it once, which is a big advantage, but I rewrote the whole thing in half a day. So, yeah. So that was, but it would, make sure that the code worked. And that was something I can't give up at this point.
Yeah.
It's always got to work.
All your readers appreciate it.
Yeah.
One of the things I liked about the format of the Atomic Kotlin book was, I didn't get this when I printed it myself because I printed it just in black and white. But you have nice color coding on the code samples too, and that's done through the Markdown code blocks or whatever or something, right?
Yes, the LeanPub does the color syntax highlighting, and I can't remember what it's using, but it allows us, once they change it so that we can have more choice. Right now, there's no choice over what the syntax highlighting looks like.
Right.
And we, once we're able to do that, we may choose something else and put up a new version that we think is nicer.
Yeah. Now, have you considered a dark mode for your code samples? Dark mode is like, everybody's like, dark mode. GitHub just launched dark mode for GitHub.
I think some
people just really care a lot about dark mode. I don't care.
I think, at least my VS Code configuration is dark mode, and I don't know if I set it that way, if it came that way.
I think it's the default in
is
VS
it now?
Code. Yeah.
It was. It's nice. It does seem easier to read, but I wouldn't know.
It's weird because there's different situations where when somebody's doing a screencast or a presentation, I find dark mode really hard.
You don't want to use it there.
Yeah.
Yeah. And I've seen people do that, and you realize, especially if you're sitting towards the back of the room or whatever, and you get two things always happen. They don't make it big enough, and you're going, okay, this tells me a lot about you, that you're not thinking about the audience, because you always want to get all the extra peripheral stuff off the screen. You want to make it so big that it almost wraps.
Yeah.
And because everybody will appreciate that.
Yeah. And, speaker pro tip. If you're going to put code on a screen, walk to the back of the room and make sure it looks good.
Mm-hmm. Yeah, do that. And also, just make sure it looks good. Because if you insist on doing it in dark mode because you like dark mode, and you go to the back of the room and look at it, you may change your mind, because it doesn't work so well in that scenario. Yeah.
I guess if you aren't reading on a Kindle or ebook, then you can, like, the default on Kindle is dark mode or light mode. I forget, but you can toggle it.
Yeah, I haven't tried it on mine. Mine is the light background. Okay. It looks like a piece of paper.
Yeah. But I think you can toggle it to the Kindle to dark mode. So I guess if people want to read your book in dark mode.
Yeah, because it's available on all of the, you can put it on your iPad or your Android tablet or your Kindle. Yeah. It's got all the formats, which is very cool. This is why I'm a fan of LeanPub, is because they're...
So LeanPub takes your markdown and then generates the different EPUB, the whatever formats, and the PDF for printing.
And the PDF for printing, amazing. Which was nice. I mean, I've got my fingers crossed that works well, but I think other people have used it and it's worked and everything. I mean, you need to, I just, wrote a Python script to do that, because there's some special stuff you want to do. You want to turn it to all black and white and everything. So, but it's basically effortless. I do a command and then I generate the PDF, and it's so much nicer.
Are you going to print it in color so you get the color
no,
code highlight? No. I have seen some books now.
Yeah, you see books do that. It's expensive. I mean, I guess if there was demand for it, I could do a special version, but
color edition.
But the color edition would cost probably twice as much as the black and white edition. So I'll just see how this works. And
colored ink is
you have to have different paper, and then you got the colored ink, and I mean, basically every page is in color. So that's a lot. That's going to really increase the price of the book.
It'd be interesting to know what the price difference is.
The other thing is, if you want the color syntax highlighting, you can just get the ebook.
That's true.
So it's
or pull the code into your IDE and then.
Yeah, I mean, there's an on screen version as well.
Yeah,
that you can just.
Well, I mean, you could just get your GitHub repo and pull it into your IDE and read the code that way.
Mm-hmm. Yep.
Yeah. Well, that's exciting. Congratulations on getting that done, and look forward to buying my copy and giving you that 1-star review.
Yeah, well, it's always a risk.
That's right. So on the topic of Kotlin, next week I'm doing a JetBrains webinar on server-side Kotlin and Google Cloud.
I thought you worked for Google.
Yeah, server-side Kotlin. It's awesome.
Right.
So we've been at Google Cloud. I've been doing a lot to help build the server-side Kotlin community and show people how to run Kotlin on Google Cloud and all that. So I'm doing a presentation about this next week.
So what makes server-side different from all other Kotlin code? What's special about it?
Nothing special about it. It's
just writing Kotlin.
You're just writing Kotlin. Yeah, okay. And some of the frameworks don't support coroutines, but most of them do. And so if I'm using Micronaut or I'm using Spring Boot, then I'm just writing.
And there's a Kotlin framework too, isn't there? What's it?
Oh, Ktor.
Yeah.
Yeah. And I've used all of them. I just used HTTP 4K for the first time today, which is another Kotlin server framework. It's I think there's some really exciting things going on there, and there's a lot of people beginning to adopt Kotlin on the server. DoorDash, which just IPO'd, their like backend is all Kotlin.
Nice.
Yeah. And then I just saw a case study from Adobe on their use of Kotlin on the server. And so there's a lot of big names now. I keep running across like kind of more stodgy Java enterprise companies that have moved to Kotlin, and you're like, really? You all moved to Kotlin?
Wow.
Like, so it's happening.
So Kotlin's getting some cred on the server then.
It is. Yeah, it's really taken off. You know, a lot of people really just see Kotlin as being the Android language. Yeah. But and it certainly has the most adoption on the Android side, but the server side has really taken off for Kotlin usage. And related to this, we haven't officially announced it yet, but we just tagged the gRPC Kotlin 1.0 release this week. So,
and you've been working on that.
Yep. Yeah. So that was exciting. We'll make the official announcement next week, I think. But so, yeah.
So I could call Kotlin from some other language.
Yeah, full RPC between kind of all languages at this point. So, so yeah, that's been fun. But yeah, if people want to check out that JetBrains webinar, if they're interested in server-side Kotlin, go for it.
Nice.
Yeah. Let's see. On the Scala front, so there was recently a blog post this week about GraalVM, and with GraalVM, so you can ahead of time compile your JVM based applications, Kotlin, Java, Scala, whatever, to native executables, and I've done that and thrown those in Docker containers for running on the cloud, whatever. I've experimented with doing CLI applications,
command line interface.
Command line, thank you. And the cross compilation is a little tricky still. Like like if I'm running on Linux and want to be able to build the Windows executable, that still is a little tricky.
Were you able to do it? You
have to do it. My understanding today, you have to do that. So if you want to build a Windows GraalVM executable, you have to do it on Windows. Okay. If you want to build a Mac executable, you have to build it on Mac. If you want to build a Linux executable, you have to build it on Linux. So it's possible, but it requires those other platforms. And so you could use GitHub Actions or something like that to allow you to some kind of CI system that has the different platforms to create those executables. And so that's what some people are doing. But one of the downsides to using GraalVM versus like Go or Rust is that the executable sizes were kind of still pretty large. I mean, nowhere near as large as downloading the JDK and, all the jar files and all that. But this example server application that I have is 12. It's a Scala server, and when I use GraalVM, turn it into an executable, it's 12 megs. So it's like not too bad. But there was this blog post this week about how to compact down those executables. There's this tool called like UPW or something like that. I tweeted about it this week if people want to find out more information, but it compacts those executables down even further. So my 12 meg basic Scala server project went from 12 megs, the native executable, down to 3.5 megs. And so that now gets into the region of being able to easily distribute.
So why wouldn't
JVM
you just
based
like
CLI applications?
Or something? What's the benefit of this thing over just using gzip? Wouldn't gzip?
Oh, isn't it nice though, just to be able to like give you an executable? You don't have to.
So you're saying I don't have to know about the fact that it's been compressed?
Yeah. Yeah. You just run it. It's
okay.
So
that's why.
Yeah, exactly. Okay. So you of course, I haven't tried to like gzip my 12 meg
and see what it
turns out to be. I'll do that experiment and see. Yeah. But this UPW tool, the output of it is still an executable, just a much smaller executable. Yes. So it's kind of wild, like to go from 12 megs to 3.5 megs, and the thing just works exactly like it did before.
And is that just for GraalVM?
No, it runs on any executable.
Oh,
Yeah.
really?
Yeah.
Oh.
I know it supports Linux because that's what I was using on. I don't know about. I would guess that it has a Mac version, but I'm not totally sure. Windows, I'm not sure. But so then I was like, okay, now like CLI applications with GraalVM become a lot more real. Like I built this one GraalVM application, CLI application, and it was like 30 or 40 megs or something. I was like, that's kind of too big to like be like handing people. So it would be really nice, to have it down in under 10 megs or something like that. So now I know this tool and know that it works on GraalVM applications, which was cool. So then a related announcement this week was the ZIO project, which Bill and I love.
And that's
the Scala
ZIO, right?
ZIO, yep. Okay. Scala ZIO. They announced their new CLI framework for ZIO. And so it's built on top of ZIO. So you get all the nice bifunctor IO, like wonderfulness of ZIO, but for building CLI applications. So I haven't tried it yet, but I really want to experiment with ZIO CLI and GraalVM and now this UPW tool. And this could be the new way that I build all my CLI applications.
Would that work with the Scala scripting stuff?
Yeah, I think you could possibly do it with Scala scripting. I'd have to look into that, but yeah.
Okay.
Yeah. Speaking of scripting stuff, did I show you my Kscript thing that I did recently?
I don't think so.
Recently?
No.
So I found this project called Kscript, and what it allows you to do is
that's the Kotlin scripting stuff.
Yeah, right? Kotlin scripting. What it allows you to do is write a KTS file, so foo.kts, and so you don't need the def main or anything. It just it run. It's like a script. But what's amazing about it is you put this like special header up at the top of the KTS file. And then you mark the KTS file as executable. And so somebody from the command prompt just goes /foo.kts, runs the KTS thing, and Kscript underneath the covers, because it's got that little header at the top, it does this magic where it goes and fetches the Kotlin compiler, compiles your Kscript file, and then runs your Kscript file. And so it gives you this experience that's like running an executable KTS file, but obviously like it's not actually running the KTS. It has to go through the compilation step and then run it, but it does all that behind the scenes for you. So it was a fun little experiment of writing like a CLI with Kotlin scripting.
Python, there's a trick you can do that with, like Windows batch files. Shell scripts are better, but since I mostly use Windows, the Windows batch file thing, and you can put this little couple of lines of batch code so that the rest of it is Python. The only problem is that when you're inside of an IDE like PyCharm, it doesn't, it thinks it's a batch file because it's got the batch file extension and it's the first lines, and so you don't get all the nice Python stuff. So
so in the case of Kscript, it is a KTS file, and so in my IDE, it actually recognizes it, and they did some work with KTS, with the KTS file format, to enable them to have that like magic part at the top, which does all the bootstrapping and compiling and running, but it still is valid KTS. Like for instance, you need to run it on Unix, you need the shebang. So it's called, the first line is the shebang, which is $, exclamation point, /bin/bash or whatever. And so that, I think that's not typically valid KTS, or at least wasn't in the past. Right. And so they changed, they
recognize the shebang.
So now they're like, now KTS can have a shebang at the top and it's a valid KTS file. So they've done some things to make the experience really nice. So I was pretty impressed with Kscript.
Cool. We didn't really play with it much because it was too early. And so I don't really have any experience with it. But the idea is nice because, being able to focus it's nice to know lots of languages, but it's also nice to be able to not have to be jumping from one language to another when you're within a project.
Yeah. So that's some exciting stuff. Other news this week, I guess there was a bunch of interesting things that kind of came out this week, but one that I saw was that Spring Boot announced support for cloud events. So cloud events is this new cloud native specification for event packages that can be a payload, typically over HTTP, but could also go over other protocols as well. And so it's kind of like this agnostic event format. So an event has an event type, can have an event type version, and so you can say this is a cloud event for let's see, what would be an interesting event, a GitHub pull request or something, right? Like so let's say GitHub pull request, they want to be able to publish a standard event format that then any consumer could hook to and be like, oh, I know how to read a GitHub pull request event. And so it has the name, the version, and then the payload body. So just like a standard kind of envelope for sending around events. So this is now the cloud native cloud events are a specification under Cloud Native Computing Foundation, and so there's now the standard spec for how to define what is an event. And there's a number of things that have now built in support for cloud events. So Knative events, which is built on Kubernetes, like this event serverless event system for Kubernetes, its default message format is cloud events. So that was one of the first places where cloud events were used. But now Spring Boot also has support for cloud events. So what's nice is that in Spring Boot now you say like I have a function that's going to handle a GitHub pull request, and that's all you say is like, I'm going to handle a GitHub pull request, and then you put your logic in there for what to do with the GitHub pull request. But if Spring Boot gets a cloud event sent to it that says, hey, I'm a GitHub pull request event that comes into Spring Boot, then Spring Boot says, oh, I know how to take that thing that's in the format of a cloud event and call your function with the parsed cloud event, with the GitHub pull request.
So I'm assuming that it's like a registration, a listener kind of a system where you say, I'm interested in that event, because otherwise everybody would be broadcasting events all the time and everything would be so noisy.
That's right. Yeah.
So it is just you go.
Usually these are like
the listener pattern.
Publish subscribe type of systems is where this often gets used. And in the case of GitHub, the way that they do events today is through webhooks. So you go in and say, all right, I want to listen for pull request events and call this HTTP endpoint with that data every time one of those events happens. And the way that this has been done with webhooks, there was no standard unification for the event format for how it got sent. So you would write your own kind of event parser.
You invent everything from scratch.
Yeah. And so with cloud events now we can have a much better standard way to have a universal event things. So the weird thing is that this reminds me a lot of the days of SOAP. I think in some ways this is just reinventing some of the things that we had with SOAP. Because in SOAP we had the message envelopes, we had the standard schema, event schemas or message schemas. Like,
what does SOAP stand for? Something access protocol. Something
simple object access
protocol. There you go. And Microsoft invented it.
Yeah. Well, and everybody was doing SOAP because everyone like wanted this thing that Cloud Events is doing now to have like this universal way to send stuff around. And obviously that didn't work out like we planned. And so now we're trying again with Cloud Events. So it'll be interesting to see how it works out this time. Yeah. It'll be interesting to see like is this better? Did we solve some of the problems that kind of kept it from being real last time?
The first time I encountered something like this was I was on the C++ standards committee, but then at the same time, I think it was some of the people on the standards committee, they wanted to start creating Corba, which is the Common Object Request Broker architecture.
Yeah.
And they designed, it was basically, I mean, it's kind of what gRPC does.
Yeah.
But it was way more complicated, and they didn't have the implementations. They would just have the spec, and you had to write your own implementations to get this thing to work. And it was just so, and to be on the committee, only like corporate entities were on the committee, because it costs several $1,000s a year to be on the committee. And of course, now we wouldn't do that, because you're going, well, we're hoping people will show up and help us work on our committee, not you have to have. So It was really, the power system was just very different. And what they produced was, let's say it didn't catch on.
Yeah.
But for a while, it was like XML. It was like, this is the hot thing. This is like what everybody's going to use. It'll be the future.
Right.
And then after a while,
it was the future for a little while.
It was totally the future.
Yeah.
And then it wasn't.
No, and then
it stopped.
Yeah.
But try and when it's the hotness, try and ask questions about it and see what happens.
Yeah.
You go, is this really the right? Oh, of course it is. Don't call out the emperor's new clothes on this one.
Yeah.
Yeah.
Yeah. So cloud events are the new hotness for creating this standard messaging protocol.
But you found it reasonable. You're finding them reasonable. Yes. Cloud events, or?
I guess I don't have enough evidence yet, because there's not very many services that are exposing cloud events yet. Mm-hmm. So like GitHub is still just using their own API format for how they send events. And I think the whole idea with this is that if everyone does it, then it's cool, right? Mm-hmm. Like if all the services start speaking cloud events.
Worked in junior high school.
If everyone starts talking cloud events, then it's useful. But until everyone is doing cloud events, it's really hard to judge it and say like this is going to be awesome or not. Mm-hmm.
Well, I guess the thing, Corba had this central committee feel to it. And so that when I see a new standard or anything, that's one of my sniff tests. Does it smell like, some opinionated people went into a room, made a bunch of decisions, and now they're handing this thing to you? Because that's the way it used to happen. And I don't think we really put up with that anymore, because we don't have to.
And cloud events was a specification that was probably defined by people who worked on SOAP specifications and Corba specifications.
Which could be good, which could be bad. It depends. If they come away going, okay, we understand why this didn't work, so let's try again and make it simpler, more straightforward, whatever. Or, I mean, the reason that I think gRPC is catching on as much as it is it's like, oh, well, there's the tools, the IDL is quite understandable, and straightforward. There are tools to convert it to whatever language I'm using, and then I can use it and it works. It's like, and it's not overwhelmingly complicated.
Yeah.
And so, and the libraries that I look at in, various languages, but a lot of them in Python, it's like, here's another try. It's not working. I can't really say why. And then somebody comes along and does it right. And you go, oh, I see why it didn't work the other times.
Yeah.
Because, we weren't thinking about it this way. And now that we are, that's the solution.
Yeah.
And, it's hard to know. I don't know. I think you get a feeling, though, when you look at something and play with it a little bit, and you kind of go, this is...
Yeah.
The thing is, you're so good at figuring things like that out that you may have lost your critical sense, because you just dive in and you figure out how to make something work.
Yeah. I think the value of having this specification for cloud events is that then you can wire things together.
Mm-hmm.
And so as an example to our pull request is that there's going to be like GitHub is the producer of that message that knows how to like produce the message. But then ideally there's, a bunch of services that I could just plug as consumers of that event, and they all know how to speak that protocol.
To be clear, I am not in any way arguing against specifications. I worked on the C++ standard for 8 years. So it's poor design. It's design that doesn't try things out and get feedback from their potential, users and pay attention to see if somebody's eyes are glazing over and this looks too complicated. And you can say, oh, they're never going to use this. We did something wrong. We need to fix it. That's the part that I think is essential.
And then, so back to the idea of like, okay, so I've got all these consumers that take in that consume a pull request event that's defined in a cloud event
that they've registered for.
Yeah. And then that maybe those things can then output a notification event or something. And then there's other services that can take a notification event and post it into Slack or email it or whatever. And so this like idea of being able to build a event handling pipeline just with like dragging and dropping things together, like that's the dream.
We're that
but
much
we've
closer
never
to
seen
no-code.
This actually work, right?
Well, I keep reading articles about low code and no code that it's apparently happening next year, and our lives are going to change. So maybe this is what's going to make that happen. Who knows?
Personally, I guess it's worth thinking about like why this hasn't worked in the past, and like generally, like I think there are some examples where it has worked. But it hasn't ever worked at like the industry-wide level that people have said that it is for.
It's not like ladder logic for control systems, which everybody still uses to build industrial control systems. And it was like they made it somehow, I guess, straightforward enough and standard enough, and they got everybody using it. And so if you are messing with a control system, even if it's in software, they're still using ladder logic.
Yeah. I think that's the hard part is you got to get everybody to use it. And it has value when everybody uses it. And so I could see like with cloud events, if everyone is using cloud events, then cloud events would have a lot of value.
Sure.
So maybe that's what like part of what went wrong with SOAP was that for a variety of reasons, not everybody used it. And so remember the whole idea of UDDI?
I remember the letters. I don't remember what it did.
Universal Discovery something Directory Information.
Right. And then
so the idea was that
and Java had that thing that Bill Venners worked on for so long.
Genie.
Yes. Wasn't that kind of the same thing?
Yeah. Yeah, they were.
And it was for connecting printers.
That's right.
I asked him once. I go, has anybody ever used has anybody ever connected a printer this way? He goes, no. Is there another example? So it's just like, oh, poor Bill. He's put so much of his. But he learned a lot.
So with UDDI, the whole like pitch of it was that there would be this directory of services, and because they were all based on standard defined message types, let's say that you need to use a service that's going to like look up a stock price or something, and there's a bunch of different vendors in the UDDI registry that have an implementation of that service. And so the whole pitch was that you could look up your service that you want to talk to, but you could also, because there was standard message formatting, you could also dynamically select which provider you wanted to talk to. So like maybe prices are fluctuating for the usage cost of a service.
It's a marketplace.
That's right. It's a marketplace. And if market provider A is cheaper than market provider B, then I'm going to make my calls to market provider A. And if all of a sudden I want to like, the price on B goes down and I want to start making calls on B, like it all just keeps working magically because everything's standard message formats.
Mm-hmm.
And yeah, that obviously we never even got close to that. Like, just, isn't it such a compelling idea?
What? Yeah, but were they solving the right problem in that case? It's like, and I understand when you set it up, you see these peripheral things. You go, oh, it could be a marketplace. But then somebody starts emphasizing that and people get the wrong idea of what it's for. And yeah, it's, it reminds me of when I was much younger, like, somewhere between age 6 and 20. And I would invent things in my head and it would just come up with, this would be so cool. And so I recognize when somebody's done that without like saying, well,
this would be so cool.
Will anybody actually, does this
solve a real problem?
Which was very hard for me because I really got stuck in the cool part.
Yeah. Yeah.
And the
cool doesn't necessarily mean that it's solved a useful problem.
No. And if you, and the exciting thing is if you actually do solve a useful problem, then a whole bunch of people get excited about it and start using it.
Yeah.
Whereas if you just solve a problem that's cool in your head, then, crickets.
Yeah.
And that's very disappointing.
UDDI definitely seemed like it was cool, but it didn't really solve any real problems.
Yeah. But the problem is when this stuff is coming out, you don't know.
Right.
It's
the hindsight is.
Well, right. It comes out and you go, maybe that's a real important problem that I just haven't been aware of.
Right.
That I needed to solve. And then sometimes a lot of time has to pass and you go, oh yeah, XML wasn't the be all end all of everything. Like, man, I don't know. The number of times that our industry has gotten into a frenzy about things and then totally forgets that they ever did. I remember in the 90s, we had the AI revolution, which was totally driven by marketers. They were just going, yeah, AI, it's magic. It solves all problems. And we're just about to get it. And there was all this money that was going into these AI companies. Turned out to be a total scam.
Yeah.
Yeah. But at the time you're going, well, and that's why I'm very careful about this low code, no code thing, is because it smells a lot like the AI revolution. But at the same time, we should get there. I mean, like just in this town, I go into businesses and I see, wow, these people need better software, but, maybe they're not a big enough business to justify that.
Yeah.
And if they could use these tools and put them together and make their own software, I don't think we're going to be out of a job. I think they're going to be coming to us and saying, I have this working and then I have this other piece I need made.
Yeah.
And so I think it's going to expand the demand for programmers and not reduce it at all.
The only place where I've really seen the low code, no code thing work is on Salesforce. Yeah. At least in modern times. So I think actually where it's worked most successfully is with spreadsheets. Mm-hmm. Spreadsheets are the ultimate low code, no code.
And that is used as an example.
Yeah.
Yeah.
So so spreadsheets by far the most successful low code, no code environment that anyone can figure out and basically build a information system in. Then remember Microsoft Access?
Sure.
That was actually a really successful low code, no code environment for building data driven systems.
There were a bunch of those. I mean, Access was kind of like.
That's right. Yeah. Access was one of some others.
Well, and the original DBase 2 was kind of like that. People could learn to program just with that and get useful results. And
so Salesforce, I think, is the new is that it's targeting the same problem, but it's cloud instead of like Access and all those where either client server or single machine. So Salesforce has actually been successful at that, but the problem with these are always that there's no escape hatch to these. Like when you hit the wall of what you can do and what you need to do, you you can't do what you need to do in that tool, then you're just kind of screwed. Like, okay, learn Python and learn, a programming language, learn dependencies, learn libraries, learn HTML and JavaScript and blah, 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 like learn all these things. And that's obviously not a good kind of stepping.
It's not a stepwise.
Yeah.
It's a cliff.
Yeah.
Yeah. And, as easy as people have made it to learn Python, you're still basically starting from scratch. Here you are, functional with Excel. And now all of a sudden you're doing, I mean, I would say Python is a fairly easy path to that. Like, I saw a YouTube video just in the past week where this guy was showing how to manipulate Excel spreadsheets. And I initially thought, with using Python, and I thought, well, surely he's just going to extract the CSV format and manipulate that. But then he says, I pull in pandas, and then pandas has this open Excel spreadsheet, and he's manipulating it in its native format and doing interesting things. And it's like, oh yeah, okay, when you run out of speed there, it is possible to step into something more powerful. But as you say, now all of a sudden you're going from, I can mess with a spreadsheet, to I have to know what a programming language is. It is a cliff. Yeah. So,
So I think that's always been my beef with the low code, no code things is the cliff mentality of them.
Well, and this is why I'm so suspicious of the whole thing, because I'm seeing articles, but I'm not seeing really examples.
Yeah.
And so, and yet behind all this, it's kind of like what we talk about with the happy path. It's like, we need to get there so that our friend Arvin, running his bookstore, can say, my bookstore software doesn't work anymore. I will just put together my own.
Yeah.
And now I've solved my problem. And that's not taking anybody's job, because there's not enough bookstores out there to run your little company to develop new software for it. It's too hard. Yeah. That's the problem. Yeah. We're still developing software is still too hard.
Yep.
And so we need more people to be able to, we need people without computer science degrees to be able to develop software.
Yeah.
And that's not a bad thing.
Yep. Yeah.
And people who do have computer science degrees will still have more work than they know what to do with.
Yeah.
It's not a threat.
Yeah. The Salesforce has been really successful at kind of the diversity element of kind of programmers because of their low code, no code. They've been able to get so many people who were doing like, I don't know, like IT kind of work, but didn't know how to program, building IT systems on Salesforce. And so this opened them up to a whole new audience of people who are not computer science trained to be able to essentially become programmers in the low code, no code environment. So it's actually been really cool what Salesforce has done to like open up the opportunity to a whole new segments of people.
And if memory serves, they've done pretty well doing that. Weren't they able to buy a really big, tall building in downtown San Francisco?
They've bought many big, tall buildings. And they actually just acquired Slack this week. So.
They did?
Yeah.
Okay.
For $22 billion or something like that. So
wow.
Yeah. Crazy.
That is crazy.
So they've been very successful, but it's been cool that their low code, no code thing has supported the ability to reach a whole different audience of developers, essentially.
Which I think
they call them trailblazers.
Oh, I see. Well,
I've been through this Salesforce marketing training.
Uh-huh. The mind washing.
That's right. Yeah. Yeah. So, cloud events. I think it's interesting that progress is happening.
Mm-hmm.
I think for me, the jury's still out on, is this going to solve real problems that we have, to your point? I'm not sure yet.
Sure sounds like, this or something like it. It's being able to send events, requests, messages, whatever, to other systems. Seems like kind of a lot of what we do now on the frontier of the web. So making that work better, whether this one will be the one that does it, or because it does seem like to me flexibility is really important. It seems like the things that win out are the ones that are clear but also very flexible. So if I send you an object and it's got a header on it, and you can figure out everything from the object based on the header and decide if you're going to do something with that whole object or with portions of the object, and you can pull them out, et cetera, et cetera. It has that kind of flexibility because that, just because your system makes up an object, that system isn't necessarily going to be able to do anything useful with it. And it might not have been updated for 10 years.
Yep.
So it's got to work under all those conditions.
Yeah.
And I wasn't in the room when they were designing it, so I can't say for sure.
Yeah.
But it's probably a step forward.
Probably. Yeah.
And then people will try it and go, here's why it worked, or here's why it didn't work.
Yeah.
Here's what we need.
Yeah.
It's the feedback system that is the important.
Yeah.
On so many of these things.
Yep.
So how do you do feedback?
Do
you ignore it?
Yeah, that is the hard thing, huh?
Never seems to work when systems ignore feedback.
Yeah.
Oh, it's not important feedback. Yeah, maybe it is. You don't know.
Yeah. So then on one last topic for new announcements this week is that DataStax, which is the company behind Cassandra, the open source big data database thing, and they announced that they're doing Cassandra Serverless. So this is a pay for what you use Cassandra service. So their traditional model was you would pay some amount of dollars every month to run Cassandra,
regardless of how much you
use it. Yeah. And so they announced that they're going to do Cassandra Serverless, which is super exciting because I've tweeted a number of things recently about how I think what I really want, and what I think a lot of other people want, is the ability to take a database, for example, and I want to run it on my laptop via TestContainers, be able to run that thing on Kubernetes for my production system, and be able to run it serverlessly for things that I don't want to run on Cassandra. But portability across all three of those environments, to me, is just essential to anything that I use. And there was really only one kind of database that fit all of those three portability categories, and it was Kafka. Kafka is not really a database, but you can kind of use it as a database. But it was the one thing that I could use in all three of those ways, because they have Kafka serverless, they have Kafka operator for Kubernetes, and they have a test container for Kafka. So it allows me to have portability, full portability across all those, which is exactly what I want. And so now DataStax adds Cassandra to my list of services that are actually portable.
So what makes Cassandra work? I mean, what's different about Cassandra from other databases? Like for me and the listeners who don't know what Cassandra is.
I've only used Cassandra a little bit, so I'm not an expert on it. But it's a distributed database is one of its key things. So it's able to distribute across nodes, and then there's different ways that you can define your kind of consensus, what you need for consensus with a given piece of data. So,
but is it an SQL database, or? I'm
sure they have a SQL interface for it. I've not used SQL on top of it, but I'm sure.
But it has its own query language then.
I've just used Java or Scala to talk to it, the APIs, and that's super straightforward. But I'm sure there's many different ways to talk to it. Cassandra's been around now for a long time, so it's one of the most used kind of big data stores.
The name keeps.
So I guess that basically everything that you would want exists for Cassandra.
It's an interesting name to choose for a database because
is it some Greek
god
or something?
It is. Well, what the Iliad.
Yeah.
Anyway, Cassandra was, I think she was in Helen's retinue. I'm not sure. Anyway, she was in Troy, when the battle and stuff was going on. The thing about Cassandra was she could see the future, but no one ever believed her. It didn't matter. Wow. Like everything she saw always came out, and their response would be, wow, you got it right, but we don't believe you can do this. Even though every time you predict something, you get it right, but we still don't believe that you're able to predict the future.
So I wonder if they were thinking about that and data consistency or something when they were coming up with a name for it. I don't know. But so when you do a write to Cassandra, I think that's when you can specify if you want it to just be like fire and forget, like maybe sensor data. It's like, okay, if you like lose some, or you can say like, I want to guarantee that this write happens to at least one node, or you can say, I want to guarantee that this write happens to a quorum of nodes.
And it's all available after I'm done so that I don't have to think about people getting wrong data.
Right.
So you have all those choices.
Yeah. So some databases are just like eventual consistency is just how is just reality, and deal with it. Whereas I think Cassandra gives you more control over the consistency. So if you don't want eventual consistency, you want
and you're willing to pay the price,
and you're willing to pay the price of
waiting,
then you can do that. Or if you want something in the middle, like a little bit of eventual consistency or something. So,
that sounds very thoughtful.
So I'm actually super excited to spend more time with Cassandra now that it fits my criteria for being portable. So yeah, so I thought that was interesting. And it's available
now?
There is currently a beta for Cassandra Serverless. It's called it's like DataStax Astro Serverless or something like that. So I hope that more services go the same direction of offering those three things: pay for what you use, serverless, Kubernetes operator, and TestContainer. And that's what I want. That's that for me. That's the golden triangle. Path. That's my happy path for services that I build against.
Nice. So have you made any inflammatory tweets this week?
Always. There was actually some related to this DataStax Cassandra one, where I was pointing out that I think enterprises, they don't want your managed service, like pointing my finger at things like DataStax and other services, cloud services, those sort of things. So what I was saying is that I don't think enterprises want your managed service. Enterprises want Kubernetes because for them, they want much more control, flexibility. Typically, they probably need to be able to run like on-prem or across different clouds, and so Kubernetes is the best way to do that today. So what enterprises want is Kubernetes, but they don't want the managed service. But what developers in enterprises want, they don't want the Kubernetes operator. They don't care about the Kubernetes operator. What they want is the test container so that they can run this thing locally on their laptop. And they want the managed service so that they can play with it. They can use it with only paying for what they use for their little toy projects, because if I'm going to invest time into learning Cassandra, I want to be able to use it on my little pet projects. I want to be able to use it for real projects on Kubernetes. Like I want to be able to, run it on my
so
laptop.
Much better because you learn that way.
Yeah.
And if it blocks you from learning, then you're less likely to use it.
Yeah, so I don't know if we've talked a whole lot about TestContainers. So I'll just give a brief description. Maybe we'll revisit it in a later episode. But TestContainers takes services like Cassandra and packages it into a Docker container and then provides an API to that Docker container, essentially, so that when you run integration tests on your laptop or in your CI environment, it will go spin up the Cassandra. In this case, Cassandra, there's test containers for all sorts of different services, but in the case of Cassandra, it'll go spin up Cassandra for you in Docker on your machine or on your CI environment, then give you the connection information to talk to that Cassandra instance. So
does it preload the data and stuff?
You can preload data. Yeah.
So it's kind of like mocking, but you're running it on an actual
you're running the actual thing, which is that's what you really want to do for integration tests is actually run against the real thing.
Sure.
And so the test container, the nice thing about it is it's the same Cassandra that I'm going to use on Kubernetes, the same Cassandra that I'm going to use in their serverless environment. It's the same. So when I run my integration tests, if those integrations tests pass, then I'm pretty darn sure that it's going to work when I'm running on Kubernetes or in the managed serverless environment. So that's the benefit, is having that like real kind of good guarantees around portability.
And so you can tell that by verifying that the container for the deployed ones is the same as the container for the test. I mean, the source code for the test.
Yeah. So you just say what version you want to use. And so you make sure in your test container dependency definition that you specify the same version as you use on your Kubernetes. So yeah, I love test containers, and it's become an integral part of how I work now and write my integration test. But so yeah.
Nice.
Oh, and we wanted to wrap up and ask our listeners to send us questions.
Yeah, questions. Topics that you'd like us to delve into. Not necessarily, little things, but things which you think we might, spend a little time talking about. Like,
so we have a Discord chat room where people can ask post their topics that they'd like us to chat about. I think we put that in all the episode notes. Yes. So go share your topics with us.
Like a topic could be the one that I suggested to you, which is, does it ever make sense to extend the interface during inheritance?
Right.
So that's a possible topic.
Yeah.
So it's something that, doesn't have a clear answer. You could argue both ways.
Yep.
So it's kind of philosophical programming problem.
Yeah.
Nice.
All right. Cool. Well, send us your questions and topics, and thanks for listening.
Bye.